Hi everybody, I am Anthony Sandosh, Assistant Professor of Chemistry in St. Joseph College. I am handling physical chemistry. Let us discuss one topic in physical chemistry. Now we are going to see the introduction for thermodynamics, and most probably it will be the explanation of terminologies. Thermodynamics actually deals with the energy changes accompanying all types of physical and chemical processes. And thermodynamics is based on two generalizations. It is actually the first and the second law of thermodynamics that we will explain in other video. These thermodynamics are mainly based on human experience. There is no formal proof for these laws, and the laws of thermodynamics are not at all concerned with the atomic and molecular structure of matter. Thermodynamics is a fundamental subject of greater importance in physical chemistry. Um, Thermodynamics also helps to lay down the criteria for predicting feasibility or spontaneity for a particular experiment or process, including a chemical reaction under a given set of conditions. It helps to predict whether a given process or a chemical reaction is feasible under the given conditions of temperature, pressure, and concentration. And the thermodynamics also helps us to determine the extent to which a process, including a chemical reaction, can proceed before attainment of equilibrium. And the laws of thermodynamics apply only to matter in bulk, not to individual atoms or molecules. So in other words, the laws of thermodynamics apply to behavior of assemblages of a vast number of molecules and not to a single atom or a single molecule like that. Okay, it belongs or deals with a, a large quantity of substance. Okay, and now we can go into the terminologies. What is a system and what is a surrounding according to thermodynamics? System may be defined as any specified portion of matter under study. What is matter? Then now we may ask, what is matter? Anything which has mass and occupy space is called a matter. So anything which has mass and occupy space is called matter, and any specified portion of matter under study is called a system, and it is separated from the rest of the universe with a bounding surface. Also, a system may consist of one or more substances. A system may consist of more than one chemical, more than one material. So any specified portion of matter which is under study, and it will possess a bounding surface, and it is separated from the rest of the universe with the boundary. Okay, that is what called a system. Now what is surrounding? If we know what is a system, the rest of the universe other than the system is called surrounding. We can simply say other than the system is called surrounding. We can say like that. The rest of the universe which might be in a position to exchange energy and matter with the system. Exchange. The rest of the universe which might be in a position to exchange energy as well as matter with the system is called surrounding. Generally the surrounding explained or implies air or a water bath which is used with the system. Okay, so what is system? Which is with which we are doing our experiment. Okay, surrounding is which might be in a position to exchange energy as well as matter with the system. Okay, so now we have got an idea about what is system, what is surrounding. Now we can classify the system in several types. The system can be classified in several types, and there are several different types also available in the system. Okay, now we can see the types of system, some in one classification. There are three different types of a system. One is open system, the another one is closed system, the another one is isolated system. What is with which we are doing our experiment is called system. For a chemist, the chemist may do his experiment just with a test tube. For him, the test tube is the system. For a computer analyst, he may do his work with the laptop or personal computer or maybe a supercomputer. For him, that system, that laptop and personal computer is the system. For a physics man, he may do his experiment with some lenses or some magnets or some other equipments. For him, that magnet or lens or the particular equipment is the system. For a biologist, for a microbiologist, the particular different kinds of culture and other needles and other things, syringe and other things with his microscope is the system. For a chemist, with which the person doing his experiment with the burette and conical flask may be the system. The flame and the test tube may be the system. Sometime it may be the RB flask and other things may be the system. Okay, there may be different kinds of system. Okay, so now in that what we are having the classification: open system, closed system, and isolated. Now we can see what is open system. Open system, for an example, open conical flask with which we are boiling something in a particular chemical reaction is called the open system. Okay, so in that case, what is the definition? A system which can exchange matter as well as energy with its surrounding is said to be an open system. So both the energy as well as matter can be exchanged in a open system. Both the energy as well as matter can be exchanged. Okay, so what can be exchanged? The definition for these types is what can be exchanged defines the type of the system. So in the case of closed system, what is called a closed system? A closed system is one. Only energy can be exchanged with the surrounding, not matter. Okay, for example, if we have a closed cylinder in a particular reaction that has to be considered, then that is called closed system. Only energy can be exchanged, not matter. Matter cannot be exchanged, only energy can be exchanged. Here energy as well as matter, both the things can be exchanged in the case of open system. Okay, next, what is isolated system? It is just like a thermo flask. If we want to keep the particular liquid's temperature in the particular temperature, means for higher temperature, that may be a higher temperature or lower temperature. If we don't want to lose the temperature, if we want to keep the ice cube, or if we want to keep the hot materials like coffee, hot liquids, coffee, tea and other things, the thermo flask, so that contains an insulator and other materials to keep the temperature. So isolated system which can exchange neither energy nor matter with its surroundings is called isolated. So energy and matter cannot be exchanged. Both energy as well as matter cannot be exchanged. Neither energy nor matter can be exchanged. Okay, this is one type of systems, one type of classification of system. In open system, both energy as well as matter can be exchanged. In closed system, only energy can be exchanged. In isolated system, both energy and matter cannot be exchanged. Clear? Now we can go into another topic, another terminology. We have to discuss in thermodynamics, we will be discussing equilibrium, various types of equilibrium. There may be different kinds of equilibriums, but now I am going to share only few equilibriums which are widely used. Okay, a system in which the macroscopic properties do not undergo any change with time is said to be in thermodynamic equilibrium. Suppose a system is heterogeneous, that is, heterogeneous means it consists of more than one phase. Then if it is in equilibrium, the macroscopic properties in the various phases remain unaltered with time. Okay, that is what called thermodynamic equilibrium. In fact, the term thermodynamic equilibrium implies the existence of three kinds of equilibria in the system. The thermodynamic equilibrium. Okay, three kinds of equilibria. So first one is, what are the three? Thermal equilibrium, mechanical equilibrium and chemical equilibrium. What is thermal equilibrium? First, a system is said to be in thermal equilibrium if there is no flow of heat from one portion of the system to another. Okay, the thermal equilibrium can be defined as, if there is no flow of heat from one portion of the system to another, then that is called that particular system is called the system is said to be in thermal equilibrium. When it is possible? It is possible only if the temperature remains the same throughout all the parts of the system. When we are doing an experiment, if the temperature remains the same throughout all the parts of the system, then only it is possible to have thermal equilibrium. Once again, I would like to repeat, a system is said to be in thermal equilibrium if there is no flow of heat. When no flow of heat will be possible, if the temperature of all the portions of the system is same, then there is no need for change of or flow of heat. But if there is not the uniformity, then there will be temperature will flow here and there. Okay, so thermal equilibrium is possible only if the temperature remains the same throughout all the parts of the system. Next, what is mechanical equilibrium? Okay, a system is said to be in mechanical equilibrium if no mechanical work is done by one part of the system on another part of the system. What is mechanical equilibrium? If no mechanical work is done by one part of the system on another part of the system, then that is called mechanical equilibrium. A system is said to be in mechanical equilibrium. We could say this is possible when it is possible. Here in the first case, temperature should be same, and in the case of mechanical, if the pressure remains the same, throughout in all the parts of the system, then only the mechanical equilibrium is possible. If no mechanical work is done by one part of the system on another part, when it is possible only if the pressure remains the same throughout all the parts. If the pressure remains the same, means one part will try to do some work on other part. Okay, so that is what called mechanical equilibrium. Next, chemical equilibrium. A system is said to be in chemical equilibrium if the composition of the various phases in the system remains the same throughout. So it is related with a chemical reaction. Okay, a system is said to be in chemical equilibrium if the composition of the various phases in the system remains the same throughout. So what is the possibility? Then the system should be the composition of the various phases should remains the same throughout the system. Then only the chemical equilibrium is possible. So these are the explanation is given for the equilibrium. Next we can go for some other properties. What are the properties? Okay, extensive and intensive properties. So there are two main properties, extensive and intensive properties. What is extensive property? An extensive property of a system is that which depends upon the amount of the substance or substances present in the system. Examples are mass, volume and energy, which depends upon the amount of the substance. That is the main thing, amount of the substance present in the system. These are called extensive property. The properties which depends upon the amount of the substance. For example, mass. If we have 100 gram, there will be a constant amount of substances. If we add some amount of the substance to the existing mass of the substance, then there will be an increase. If we take some molecules present in the some amount of the substance, then there will be a decrease in the mass. Okay, so if we add likewise the volume also. If we have a liquid of 100 ml, if we add some amount of the same substance or any other substance to the particular volume, then that will increase the volume. Likewise, when we use a particular amount of fuel for getting energy, 10 ml of a fuel, or in the flame amount of some gases or solid material that provides some amount of energy. If we increase the amount of fuel, then that will give more amount of energy. If we decrease the amount of the fuel, that will decrease the amount of energy. Likewise, if we increase the amount of the substance, the mass will increase, the volume will increase, the energy will increase. If we decrease the amount of the substance, that will decrease the mass, that will decrease the volume, that will decrease the energy. These properties which are depends upon the amount of the substance is called extensive property. Okay, next, what is intensive property? What is intensive property? There are so many properties, so many examples available for intensive property. The temperature, pressure, density, concentration, viscosity, refractive index, surface tension and specific heat. Okay, so we may discuss so many things in intensive property. Simply speaking, if I have 5 ml of pure water, what will be its boiling point? If it is pure, I already told, if it is pure water has the boiling point of 100 degrees Celsius, boiling temperature. If we have 10 ml of pure water, its boiling point will be 100 degrees Celsius. If I have 1000 ml of water, its boiling point will be the same 100 degrees Celsius. If we have 10,000 ml of pure water, if we have one full barrel of pure water, that's boiling point will also be the same. It does not depends upon the amount of the substance. It is independent of the amount of the substance. Okay, independent, whatever may be the amount. If I have 500 ml of a oil, that produce a viscosity. And if I have 5000 ml of a particular oil, the same oil, that's viscosity will not change. It produces the same viscosity. Okay, the temperature, pressure, density, viscosity, concentration and other things will not same, which is independent of the amount of the substance.